Here I have a series of indicators here in solution, and they turns out I made them in slightly basic solutions. So we have this first indicator is bromocresol green. And here is the pH range, okay? And you can see that we're blue, so we are definitely in this, well, we could be in the acidic range, but I've made it slightly basic by adding a small amount of ammonia. I used some distilled water and added a small amount of ammonia. Now I'm going to tell you something that's going to freak you out if you're a new teacher. If you take distilled water and you add an indicator like this, this may actually turn out to be very slightly green and not blue. Because when you take distilled water, unless it's freshly boiled, it's going to have some carbon dioxide in it. And what carbon dioxide does, let me take this down for a second and show you. What carbon dioxide does is it can react with the water. It can dissolve in there. Carbon dioxide, if you teach AP chemistry, is known as a acid anhydride. It's a non-metal oxide. Non-metal oxides can dissolve in water to form an acid. In this case, it's carbonic acid or carbonated water. Now, it's a weak acid. And that weak acid can react with some water to form the hydronium ion and some hydrogen carbonate. Okay? So what happens with distilled water is it lays around, carbon dioxide from the air gets in it, and it turns slightly acidic. So if you have deionized water or distilled water and you put your indicators in there, be prepared to futz with them a bit to get them to the pH range you want. The second one we have is phenol red. And again, you can see it's in this red range, okay? And the third one we have here is methyl red, and it's in the yellow range. That's a bit disconcerting. Methyl red, it's yellow. Well, it's in the basic range. It's in this slightly basic range. And then we have bromothymol blue. And it is blue, so life is good. And here we have the same things. These are going to be our controls. I'm not going to do anything to these, so then we can compare them with the endpoints or when these kick over. You don't have to do these in this fancy glassware. You could use 1 liter or 2 liter pop bottles that you cut the top off, and you don't have to use this large amount. You could use a small amount. And it doesn't take a lot of the indicators to do this either. And these are all, again, slightly basic. And I want you to keep in mind that as I do this, the indicator itself is an acid or a base. The indicator itself, in this case HIN, where IN is some organic molecule, organic part normally, it can react with the water to give you H3O plus and IN minus. So if you add an acid, you'll shift it this way, it'll become red. If you add a base, it would become, in this case, the indicator is kind of a sick greenish yellow color. So it will switch back and forth. So it's an equilibrium, and you can kick it back and forth. And that's what we're going to do today with these indicators, because we're going to be starting out in the basic range, and we're going to add, as I said, an acid anhydride, in this case, carbon dioxide. Now, I'm not going to breathe over these. I'm not a heavy breather with this sort of thing. I'm going to use some dry ice, carbon dioxide. And as you know, carbon dioxide is solid dry ice, it's pretty cold, minus 78.5 degrees Celsius. And you could stick your tongue in that if you wanted. Then you'd be like, what was that movie? Christmas Story with the kid in the flagpole. This is a flagpole on a really bad day. You don't want to do that. That's a bad thing. Instead, I'm going to drop it in here, little pieces of this. And as I drop it in theory, we will form carbonic acid. And if you look, you may be able to see the kickover point where it kicks over. So we're going to start there. There's 1. There's 2. There's 3. I'm missing. There's 4. And this may take a while. Oh, this one kicked over. This one kicked over. This one kicked over. This one's being ornery. I may have put too much base in it. Let's see, just to make sure. This one was pink, now it's yellow. This one was yellow, now it's reddish color. It's the third one. This one was blue, now it's yellow. This one's not kicked over. So let me put some more in. Go! Now I'm going to remove these two because I'm going to do something else and I've got time. And we're going to take a look at this first one. We may never be able to get over there. And we're going to see why in a moment. Because we're going to use some universal indicator instead. I'm going to leave this one sitting right here. And here I've got one with some universal indicator in. And Flynn sells a universal indicator chart like this, but that's kind of hard to see. So I had it transferred to a board. The other thing is for an overhead, and that's becoming old technology apparently. I like to call it a photon projecting device, then it becomes high-tech. So here we have the universal indicator. This consists of a series of indicators. And in this case, it's a pH of 10 or above in this solution here. I made it basic again with some ammonia. And as I add the carbon dioxide, you will go through this series of color changes, and I want you to see where it ends up, okay? So let me grab my glove, because you don't want to grab the dry ice with your bare hand. And let me put this number 1 here so you can see. This one did change, but not all the way, and we're going to see why right now. So here's my chunk of dry ice. I'm going to drop it in there. And by the way, when it goes through the green, it's going to go quick. If you teach AP chemistry, you can talk about that. All right, there we go. Look at that. We've already bluish color. Oh, nice. There's the green. There's the green. Go away. Oh, look at that. It's amazing. It's voice activated. Now we're yellow. But pH, we're going to get any. It's not turning anymore. Maybe another piece of dry ice will help. We're kind of stuck between 6 and 5. You see that? Somewhere in between, and I can't get it to go anymore. That may be part of the puzzle right here. By the way, this white stuff here, that's not carbon dioxide. That is a colloidal dispersion of water droplets. Those are little water droplets that are being kicked up. As the carbon dioxide sublimates, it gives off a gas. The gas comes up and knocks some of the water droplets out, and that's what you see there. There's also obviously some carbon dioxide gas coming off, but that's going to be colorless. This is it, folks. This is as much as we're going to get with the color. So I'm going to pour some out, okay? And since we're not supposed to pour in the drain, I'm going to use one of these other beakers here, because I'm going to want to get this to red. The reason this didn't really go past this between 5 and 6 is carbonic acid is a weak acid, so it's never going to do that. We are saturated right now, and we're not going to kick it over. So I got a strong acid right here. I have some hydrochloric acid. Then we can get it to the red color, pH below 4. Ooh, look, didn't take much. This is a 2 molar solution. Doesn't really matter, whatever you have laying around. Now you're going to say, I missed the whole bloody thing. Can you do it again? So we're going to neutralize the acid with the base. This is the classic base, sodium hydroxide. And if we're quick, we can get it. There it is. It's purple. And we can start the whole process again. Unfortunately, I may have put a lot in, so it may take a good portion of the period. Many of you would be happy with that if you were my students. Yes, please do. But you can see we're starting to go through. Eventually, you will get kind of a buffer solution, and it won't work well. If you want to use these solutions again next period, you don't have to make them up. All you have to do is put some ammonia in there, kick them back over into the other range. Okay? Kick them back over to the basic range again, and you can start again. Everything is set up. All right? And as you can see, we kicked over with the universal indicator somewhere between, let me make sure I have it right, somewhere between 6 and 5. And you notice somewhere between 6 and 5 here is this kind of greenish color. So it's never going to go over to the yellow color with the carbon dioxide. I know what you're saying. Can you add hydrochloric acid to it? Let's try it. Ta-da! Life is good. All right, so there's a lot of information in here. Indicators, acid-base theory, and carbonic acid, and shifts back and forth. And I find this to be one of the most fascinating and colorful demonstrations that I do all year, and I think my students enjoy it too.